Good afternoon, and thanks for joining us for the 22nd webinar in the Offshore Wind Series, Learning from the Experts. I'm Peter Lyon, Senior Advisor to NYSERDA's Offshore Wind team, and it's my pleasure to be joined by today's expert, Noé Rouxel, with DNV Offshore Wind. Before I introduce our speaker, a few reminders to our participants and some background on this webinar series. Next slide. Firstly, if you're experiencing any technical issues, please contact Sal Graven at the email address on the bottom of this slide. This webinar is being recorded, and the recordings and presentation slides for all webinars in the Learning from the Experts series will be available on NYSERDA's website at the address on this slide as well. All participants have been muted. We will have time for Q&A following the presentation, so please use the Q&A function to submit your questions for the speaker. Next slide. So, New York State is working to advance the responsible and cost-effective development of at least 9,000 megawatts of offshore wind by 2035. Offshore wind is a critical component in achieving the state's goals of 70% renewable sources of electricity by 2030 and 100% zero emissions electricity by 2040. While offshore wind has been providing clean energy to other parts of the world for several decades, this industry is brand new to New Yorkers. To provide interested stakeholders and members of the public with accessible, impartial information and opportunities for engagement on specific topics of interest, NYSERDA is hosting this educational webinar series called Learning from the Experts to connect the public with independent experts in key topic areas of offshore wind. We endeavored to select Learning from the Expert speakers based on their expertise, not necessarily for an alignment of opinions with NYSERDA or the state of New York. If you would like to suggest a topic or a speaker for a future webinar, you can email us at offshore-wind@nyserda.ny.gov. Please note the views and opinions expressed in this presentation are those of the presenters. Next slide. It's now my pleasure to introduce you to Noé Rouxel. Noé is a project manager at DNV Offshore Wind North America with a background in naval architecture. He has 11 years of experience in the offshore wind industry and specializes on the design, construction, and installation of offshore structures. Noé started at SBM Offshore, working on the design and construction of floating oil and gas platforms. Since 2016, he has been immersed in the offshore wind industry development, including the design and development of floating offshore wind platforms and offshore operations and installation of offshore electrical substations in the Baltic and North Seas. Since joining DNV, Noé has been supporting the development of multiple offshore wind projects on both the East and West Coast in North America. Thank you all for joining us today, and now over to you, Noé.
Thank you, Peter, for the introduction. And good afternoon, everyone. Good morning on the West Coast. So today's presentation, I will start with just first introduction of who is DNV. I promise to keep it short. Then we are going to cover the whole maritime activities on an offshore wind farm and to understand all the kind of vessels that are involved in this activity. So it's going to be a quite quick but almost comprehensive overview of all kind of vessel involved on a wind farm. Then if we have time, I will give a bit more detail on some of the most impactful vessels, but even if I don't, please don't hesitate to ask me questions later on. Then we'll cover the Jones Act, what it is and what are the effects on the Jones Act on offshore wind construction in the US. Then the expected demand in terms of vessels in the US. DNV has performed a study recently together with NREL and the business network, so I will be able to share some of those results. And then concluding with some of the main industry trends that we can observe and that we can expect for the future. So first, who is the okay. First, who is DNV? DNV is an independent certification and a technical advisor in many fields. So we have more than 150 years of experience in the maritime industry, also many years in the electrical industry, offshore oil and gas, and onshore wind industry. So naturally, DNV were involved were involved from the very beginning of offshore wind industry more than 20 years ago in Europe. So we do have a lot of experience, and we have been following most of the existing projects built and under development right now. So we are most famous maybe for setting standards, standard setting, certification, but we also do quite a lot of offshore wind advisory services. So that's helping and supporting the different stakeholders through the whole phases of an offshore wind development, from the feasibility study to the development, engineering, and even construction operation. So yeah, I will not mention all the things we are doing, but yeah, I could mention feasibility study, helping with navigational risk assessment, different permitting phases, and plenty of others. But yeah, jumping right into the topic, um, which is the maritime activity on an offshore wind farm. So first, before talking about the different activity, what's important to understand is that there are different phases during the life of a wind farm, and during each of those phases, there are really different activities happening. Um, for instance, we can divide it quite typically into four main phases, which would be first the development phase, the construction phase, operation and maintenance, and decommissioning. During the development, we would do mostly bathymetry survey, different kind of surveys, understanding the environment. Then the construction is when we install offshore, when we bring and install offshore all the different components, the wind turbines, the foundations, subsea cables, substation. So that's the most heavy in terms of maritime activity, but it's also not so long. 1.5 to 3 years for a commercial size wind farm. Then the operation and maintenance. This is most of the wind farm life actually. Actually, it's like 25 to 30 years typically, and that's the operation and maintenance. So inspections, subsea inspection, bringing technicians, minor repair, but also sometimes more heavy repairs like replacement of a major components. And then the decommissioning at the end of the wind farm is basically when we take everything off and we leave the ocean as it was before. So it's to make it simple, just basically the contrary of the construction, a reverse procedure of the construction. And that's quite interesting. This phase is quite interesting because we have really limited experience. The first wind farm were built maybe 25 to 30 years ago in Denmark, and there are just a few. So the first few wind farms were decommissioned very recently, and they are really small compared to what we are doing now. So for each of those phases, I will describe the kind of vessels that are involved. It's a quite high-level description, but I'm trying to be comprehensive, and that's probably the best we can do in 40 minutes, I think. But yeah, again, don't hesitate to ask me more detail in the questions. And again, here I'm trying to categorize the vessels into specific categories with name. It's not always that simple. Some vessels can do different stuff. Just one vessel can have different roles. So yeah, those categories can be discussed, but I think for now it's probably a good start. So starting with the development, as I was saying, we perform different kind of surveys. So first, bathymetry survey using survey vessels such as this one. The main role of this vessel is to tow or to carry a sonar, which will just measure the water depth. There are different kind of sonars, but it's a medium-sized vessels, relatively simple. Then there are geotechnical survey vessels. One of the difference of those vessels is that they are able to, that's the thing you can see here, this tower, they are able to lower some equipment on the seabed to take some sample, to make some boring through the seabed and bring back some sample of seabed to be able to analyze the different layers of the seabed. And then also we can install MeteoOcean buoy deployment, like MeteoOcean buoy, so it's like floating buoys with a LiDAR and different instruments to measure the conditions, the wind and current and wave conditions. So that's installed by smaller vessels. For instance, this specific vessel is a vessel that was installing the floating LiDAR in the New York Bight, NYSERDA floating LiDARs in the New York Bight. Yeah. So then the construction phase, which is definitely the most activity intensive phase. First kind of vessel, first activity we need to perform is transporting the components. So there are plenty of different ways of transporting the components. Maybe first vessel involved, and maybe also the most simple, is the barge, the simple barge towed by a tug. So it's just a floating pontoon, and it's usually used to carry the most the equipment with the most volume, like the very big equipment. So it could be substation foundation, substation topside, which can be enormous, and all kind of out of format equipment. Equipment can also be transported by vessel, self-propelled vessel with this kind of flat deck, and there are actually a lot of other kind of vessels. But the tendency is that more and more the vessels are specifically designed to transport wind turbine component, like this one for the blades. You have other vessels that are specifically designed and optimized to transport the nacelle, the hubs of the turbine. But yeah, again, those vessels, typically this vessel would do the transport from the construction site, like the wind turbine factory, the monopile factory, to the construction port. This vessel would not perform any installation operations. So it's purely a transport vessel from port to port. Next kind of activity is a seabed preparation. So seabed preparation can happen two main activity can be on in this category. First, the dredging, using a quite standard dredge that can be used to deepen the port access, to adapt the port access for specific vessels. That will be the case in several ports in the US. That can also be used to flatter the seabed, to make the seabed more flat in case there is like sound waves or this kind of stuff, to make it even. So it's basically a bit like a small oil tankers with massive pumps and arms like this that are going until the seabed and sucking and pumping the sand mixed with water, and then storing it and then releasing it further offshore. The other kind of vessel is the fall pipe vessel, which is the vessel used to install the scour protection. Scour protection is a mat of stone, which is usually installed around the monopile, typically, to avoid scour effect from the current, like the current digging holes around the pipe, around the monopile. So we install lots of stones, and for this we need a vessel that can precisely depose, like install stone on the seabed. So that's why we have this kind of big pipe. In the same time, the vessel is able to store lots of stone, so it's pretty big vessel with a pretty big capacity. Next activity is the installation of the wind turbine foundations. So as you may know, there are, let's say, two main type of foundation for bottom fixed, jacket foundation and monopile. For the two of those, we can be similar vessel, but basically there are two main category of vessels that can perform this activity. First, the heavy lift vessel that we also call HLV, that's floating vessels with a massive crane and a very large deck, which is able to carry those components and also to lift it. So this crane, like this specific vessel, for instance, has a crane of 5,000 tons of capacity. So it's way above the typical weight of a foundation. Some of the foundation can also be installed by a jackup vessel. So the difference of a jackup vessel is that the vessel has 4 legs or 6 legs on which and those legs are going down to the seabed and support the hull of the vessel during the lifting operation, which makes that the hull is actually not even touching the sea surface during the lifting operation. We will see a short video after that. And then on top of that, during the installation, since most of the installation of the foundation involve pile driving, which is basically hammering really hard the pile on the seabed, it generates quite a lot of noise, and to protect the sea mammals, we are creating bubble curtains around the operation, and those bubble curtains are mitigating the noise coming from this operation. So this is usually performed by a different vessel which is operating around the main operation vessel and dropping and like laying on the seabed special equipment and carrying a lot of air compressor to create lots of bubble, basically. It's a big jacuzzi around the operations. Next operation is cable laying. So it can be two kind of cables, the inter-array cables or the export cables. The inter-array cable is a cable linking the different wind turbine to each other and the wind turbine to the offshore substation. It's typically a 66 kilovolt cable. And the other kind of cable is the export cable. So the cable connecting the substation, the electrical substation to shore, which this one is usually it's always a much higher voltage, typically 220 kilovolt or even higher if it's HVDC. So for this kind of operation, the cable laying vessel is a quite particular vessel. First, it has what we call a carousel at the middle of the vessel, carrying the cable, which is coiled around this thing. So it can carry kilometers and kilometers of cable, even big and heavy cable. And then for laying the cable, it's towing an equipment on the seabed, which can be different depending on the kind of seabed, but it can be a plow, just a bit like what we use in agriculture, that are like digging the seabed and laying the cable in the same time into the trench, because the subsea cables are buried, like typically 6 feet down. And it can, and there are also different kind of equipment that can be fitted on those vessels depending on the seabed, like this kind of Caterpillar subsea equipment with a kind of chainsaw that can go through very hard seabed. But all this can be installed on this kind of vessel. And these vessels are also installing other cable equipment like floating device, if it's a floating wind farm, or bend stiffener, or other kind of things. Wind turbine installation vessel, that's probably the one you have heard the most about. It's typically a jackup vessel like this one. Like you can see the 4 legs at the 4 corners of the vessel, and this vessel is, as I said, jacking up above the water level, so that the crane is really stabilized and is able to lift the mast, then the nacelle, and then each blade. So those lifts are really precise. Um, so that's why we usually use this kind of jack-up vessel to have a vessel extremely stable and which is not moving with the waves and with the swell. For information, this picture is the first and for now only Jones Act compliant wind turbine installation vessel that is being built right now in Brownsville, Texas. So a short video about typical installation sequence. Hopefully it works. Yes. So here it's in, I think this one is in Denmark. So you can see the wind turbine installation vessel coming close to the foundation, which has been previously installed, and lowering the 6 legs in this case. So it's up, and so the vessel is stabilized above the sea level. Then it's installing a small gangway for the technicians to transfer to the foundation. And then it carries on lifting the first mast. At that point, some technicians are bolting the mast with the foundation. And then it will lift the nacelle. Same here, it's all bolted. So we have technicians right here. Oh, it was supposed to be a bit longer. And then it will go on and install the blades. Okay, I'm already running a bit late, so I will try to make it a bit faster. So yeah, as you can see, all in all, it took, I mean, if you look at the sun, no more than a day, than 24 hours, which is a kind of typical time frame for this, for each turbine. But there is, typically at maybe 70 turbines per wind farm, so it's still a lot of time. Okay. Next activity is the installation of the OSS, the offshore substation. That's where the transformer is located. So depending on the technology, it can be relatively light, like 3,000 tons topside, in which case it can be installed by some of the vessels we saw before. But in some other case, especially if it's HVDC substation, it's another electrical technology. The topside can be extremely heavy, up to 20,000 tons or like 15,000 tons typically. So in that case, we might have to use this kind of semi-submersible crane vessel, which have extremely high crane capabilities. But I mean, it's also really slow to transit, really high day rate, more than 500,000 a day typically. And it's also located typically in the North Sea. So just to make it come here back and forth, it already cost millions. So I mean, sometimes we just don't have choice, but as much as possible, we try to use other kind of vessels. And then last activity, which is actually happening through the whole, I mean, it's during all the other activity, we need to transport personnel between the different vessels, between shore and the vessels, between the vessels and the structure we are installing. And for that, we use different kind of personnel transfer and accommodation mean. The first type of crew transfer vessel is actually called crew transfer vessel, CTV. You will see this kind of a vessel a lot. It's really the Swiss knife of offshore wind. It's a relatively small vessel, typically less than 25 or 30 meters, carrying 12 or 24 technicians. with a crew of like maybe 2 or 3 persons, and it's also fast, more than 20 knots. Then there are the other kind of vessels, the service operation vessel or SOV, which is transferring like first, like the main difference is that the personnel can sleep on board and stay on board for the duration of the activity. And then we are gaining a lot of time in transit. So the vessel is staying typically within the wind farm with personnel sleeping on board and transferring through a gangway. So that's what you can see here. It's a stabilized gangway. If I had time, I would show a video. It's quite impressive to see at work. And then what we can also do is install accommodation platform, temporary accommodation platform, like here. What you can see here, what you can see on the left here is the electrical substation that we were performing the commissioning on. And then we installed for 6 months during the commissioning, we installed this platform and we were sleeping on board and transferring every morning and back in the evening to this vessel. So we're gaining a lot of time. But, so next phase is the operation and maintenance. So here we covered more or less everything that's happening during the construction, and now we are at the phase where the wind farm has been built, it's been commissioned, and now during 25 to 30 years we are just operating it. So most of the activities are going to be relatively light inspection and maintenance, and for that we will use a lot of CTV or service offshore vessels. Those vessels will be, I mean, yeah, when the wind farm will be built, you will see them a lot at port. So it's transporting technicians for inspection, but also for light maintenance. It can transport relatively, medium kind of spare part, stuff like that. Other kind of vessel also performing inspection is diving support vessel, which can support an ROV, a remotely operated vehicle, which is basically a small submarine to inspect the subsea parts of the wind farm or the cable, the subsea cable, at least the visible part. Sorry. And again, I mean, I'm doing 2 categories, but sometimes it can be the SOV is able to support an ROV and vice versa. So but you have to do category to make it easier, but it's not always as straightforward. The other activity that may happen during the operation and maintenance phase, and actually statistically it does happen at some point, is the replacement of major component, like it can be a blade or even a full nacelle or a big component inside the nacelle. In that case, we need to remobilize a jack-up crane vessel because the vessel we saw before, like the SOV or CTV, are not able to lift such heavy equipment so high. So we need to remobilize this kind of vessels. That's usually exactly same kind of wind turbine installation vessels that we saw before. Just a specific parenthesis now on floating offshore wind construction, which is a bit specific. Everything we saw before, some of the vessels are applicable to everything, but for the installation of the floating offshore wind turbine, we are using different kind of vessel because the wind turbine is assembled on the foundation at port, so we don't really need to have a wind turbine installation vessel because we just do it with a land-based crane. But however, we need first anchor handling tugs, so that will be vessels that will transport the anchors, install the anchors and the mooring lines on the seabed, and also tow the floating wind turbine from port to the site. Depending on the kind of anchors, we may also need some more complex subsea construction vessels, like for instance, installation of this kind of massive suction pile. So it's a similar vessel, but a bit more, with more sophisticated cranes and subsea equipment. And yeah, and this is quite specific to floating offshore wind. I'm running a bit late, so I will jump forward directly to the Jones. So what's the Jones Act? You probably heard about it. So basically, the Jones Act prevents non-US ships engaging in coastwise trade between two US points. So basically, it means that if a vessel is transporting equipment or personnel or any kind of goods between two US ports, this vessel needs to be Jones Act compliant, which means that this vessel needs to be built in the US, have a US flag, be US crewed with only US national as crew, and also I think US owned. Um, and the thing is that the Custom Administration has ruled that the wind farm itself, the offshore wind farm, will be considered as a US port. So which means that any vessel transporting goods between the US port and the wind farm, like typically as we do with, you know, the blades, I mean, any component between the construction port and the wind farm needs to be Jones Act compliance, so US built and everything. The issue now is that since this industry is really young in the US, there are like a really limited amount of vessels that vessels that are Jones Act compliant, and for some of those there are even none. So one of the solution some of the developer are using, and you may hear this a lot in the future, is a feeder barge concept. So using in a foreign flag installation vessel, which are the most rare kind of vessels and expensive kind of vessels. Most of those vessels are based in Europe, mostly in Europe and a bit in Asia, so are not US flagged. So we could use this kind of vessels, but this vessel would not perform any transport. This vessel would stay offshore on its leg, but the transport of component would be performed by what we call feeder barge or feeder vessel, which would be a Jones Act compliant vessel doing the shuttle between the construction port and the wind farm. So and then the construction vessel would just pick up the component on the feeder vessel and install it. That's what we call the feeder barge concept. And as far as we know, it's going to be used for most of the wind farm construction in the US, at least for the next 5 years. So, which vessels are concerned, are impacted by the Jones Act? Like those vessels for sure are impacted. First, the feeder vessel and barge, obviously, as I said it, because their primary role is to transport things between two US ports. The dredge, because there is something called the Dredging Act, which is basically a Jones Act applied to a dredging, which has the same requirement. The anchor handling tugs, because they will be picking up the anchors and mooring lines at a US port and installing it on the seabed. Service operation vessel, because again, their primary role is to transport personnel between personnel and spare part between US port and the wind farm, and crew transfer vessel, same. That's the only thing they are doing, transporting goods between port and the wind farm. So those vessels, there is no much way around being Jones Act compliant. Other kind of vessel, it's a bit less straightforward. So I mentioned wind turbine installation vessel and heavy lift vessel. If we use feeder barge scenario, then it could, it can be, it's not necessarily Jones Act compliant if we use feeder barge. Same for the scour protection installation vessel. It's a bit a gray area in that case, because basically for the first layer of stone. If there is if there is nothing on the seabed, then the custom administration considers it as not a US port. But as soon as there is something installed before the seabed, so it needs to be Jones Act compliant because it's considered as US port. Anyway, it's a gray area, and there's still quite a lot of discussions about it. Expected demand. So here I want to mention a study we performed in DNV together with NREL and the business network for offshore wind. And that was a study funded by the Department of Energy. And we looked at the expected demand and the expected pipeline of demand of offshore wind farms in the US, both on the east and west coast, and how does it translate into first supply chain demand for each of the components, but also vessel demand. So the graph you can see here is the expected number of the expected capacity installed every year. So as you can see, it's relatively steady for the coming in decade every year, even increasing after some time. The blue is what have been leased already, and the green is what is expected to be leased. So it's a forecast, but so based on this, we end up with specifically for the vessel with this curve. So the one you can see here is CTV, which is interesting to notice that we do expect 40, like the need for 40 to 50 CTV by 2030, which is huge compared to the about 4 existing now, Jones Act compliant CTV. It's small vessel, but it's a lot to build. And then if we zoom a bit, if we remove the CTV and zoom on the other vessel, we do expect again about 5 WTIV and up to 10 feeder vessels or feeder barge. And similarly to CTV, an increasing number of SOV. And I mean, those numbers are estimates, obviously. We put 5, it could be 6 or 4, depending on the year. It's based on quite a lot of assumption, but it really gives a good order of magnitude. So compared to what's existing now, what is the status of the Jones Act fleet right now? Starting with wind turbine installation vessel, the only one in construction is the Chariot BIS for Dominion Energy. It's a new generation wind turbine installation vessel. It's being built now. I think it's originally planned to be delivered end of 2023. And it should be starting with the installation of the Ørsted wind farm in Massachusetts, and then the Dominion one. But that's the only one, and as you saw before, we expect the need for up to 4 to 5. And as far as I know right now, it's there is no other that have been ordered right now. The SOV, there are 2 or 3 under construction right now, but we expect much more to be ordered in the future. This one is the one ordered by Ørsted to support their wind farm in Massachusetts. CTV, last time I checked, it might be a bit more now. There are just 4 in operation and several under construction. Tugs and barge, there is a quite large existing tug fleet in the US, same for the barge, which are used for good transport, but also in the oil and gas industry in the Gulf of Mexico. It's a bit difficult to say if it will be enough or not. Most probably there will be a need for more because it's also used in the oil and gas industry. The offshore wind, we are not the only one using the vessels here. There is one scour protection installation vessel that has been ordered, which is being built in the Great Lakes. in one of the Great Lakes shipyard. And then there are several US anchor handling tugs, mostly in the Gulf Coast, and I think 2 on the West Coast in California. So that might be also a critical thing, because with the development of floating offshore wind in California and the West Coast, and maybe also later on the East Coast, there will be a need for probably a bit more anchor handling vessels. So concluding with the main trends in the industry, first, with regard to the wind turbine installation vessel, the wind turbines are getting larger and larger. Like, I remember when I started in the industry 5 years ago, 6 megawatt was a pretty big turbine. Now we are installing 12, and by the end of the decade, we are expecting up to 18 or 20 megawatt. So it's getting really big now. You know, it's more, I think like a 15 megawatt turbine is roughly 300 meters high with 250 meters, 240 meters rotor diameter. Sorry, I'm not sure how much it is in feet, but it's big. So the wind turbine installation vessel have to keep up. They have to keep up with the pace of growth of the wind turbine. So now most of the wind turbine installation vessel being ordered are bigger and bigger, with bigger crane that are anticipating the growth in turbine, bigger storage deck, like deck space for transporting goods, and yeah, and also like the other issue with this increase of wind turbine scale is that a lot of the existing fleet right now will not be able to install the future turbine. So now we have a fleet, like an active fleet, excluding China, of maybe 15 or 17 wind turbine installation vessels globally, and a big majority of them are not going to be able to install 15 megawatt turbine in a few years. So there is really a need, and right now there are lots of those vessels that are being ordered. Right now, I think there are 9 of those under construction in the world. Next thing is really the development of integrated feeder vessel concept. So that's really being led by the US because of the Jones Act. But the thing is that having this kind of feeder vessel, feeder barge, and wind turbine installation vessel staying on field is actually not too bad, because you are using your expensive vessel to do just what it's doing good and efficiently, meaning lifting big things. And during this time, you have like cheaper vessel doing the simple transport. So there are a few concepts emerging like this one, you know, with a feeder barge connecting to the installation vessel. So typically this vessel would not be Jones Act compliant, and this barge would be. Or even having a feeder vessel and not just barge, so self-propelled with dynamic positioning and all this to make the transfer more efficient. Last trend, I think it's the use, especially during the survey phase, of unmanned autonomous vessels, especially for like tasks like carrying sonars, towing sonars, doing UXO survey, like detection of unexploded ordnance. Yeah, the unmanned autonomous vessel is more and more used. I mean, for now it's not used so much, but there are lots of research, and it's almost ready to be commercially used. And I'm just a bit late, but that's it for me. So, any questions?
Thank you, Noah. That was a really great presentation and great overview of the different types of vessels that are utilized in the offshore wind industry, and a good, update on the status. really of Jones Act compliant vessels here in the U.S. that are going to be servicing the industry through those various phases of development and operation. We have had several questions come in. One that I'm really interested in as well relates to the typical weather conditions that these vessels are able to operate in, whether it's, for the assessment, environmental or engineering assessments in the early phases or the construction and then into the operations and maintenance.
Yeah, that's a great question. So as you can imagine, a lot of those vessels, like if I just take the picture, especially, the personal transport vessel, but if we talk more specifically about installation, all those installation vessels obviously cannot perform their activity and cannot operate in very rough sea condition. If there is too much wind or too much wave, obviously it's not going to be possible to lift the component with the right level of safety and precision. So depending on the vessel size, the type of vessel, we have different limitation. So typically we would have like lower limit in terms of wave for a floating vessel, for a vessel without legs, not a jackup. Uh, Depending on the lift, and would be typically like 1.5 or maybe 2 meters of significant wave height, which is relatively low. It could be a bit more for a vessel, for a jackup vessel, could be maybe, again, it really depends on many things, but a bit more like 2.5 meters because the waves are not affecting the movement of the crane. There is also some criteria on wind. And then on transport vessel, typically for CTV transfer, it's 1.5 meters and maybe 2.5 meters wave height for the SOV. So all those operational limitations are taken into account from the design phase and from the planning phase because we perform some statistics. We know in the last 10 or 20 years what have been the sea condition in the area, and based on that we do statistic to forecast the number of days in the year or per month that we will be able to work statistically. So we based our planning on this. But yeah, like typically, I mean, just to have a to understand a bit the phenomena, it's like for a wind turbine installation in a typical year, like if you take the 12 months of the year, you can, in average, operate less than 150 days in a year. So it's less than the half of the year. And obviously mostly in the summer period. So it's a pretty big things to take into consideration.
Yeah, and I know safety is of the utmost importance
That's
for
right.
any of these projects. So developers, as well as the selected contractors are, and constantly monitoring those weather conditions
Yeah.
to determine the ability to continue working safely to develop these projects. There were a couple questions that came in around some specific vessels and availability, as well as need to be Jones Act compliant. So there's a question around cable installation vessels and their need to be compliant. And then there was a question around diving support vessels. I don't know if you could elaborate on.
So on diving support vessel, if the vessel is not like transporting any goods and not moving any seabed, I don't see why it would need to be Jones Act compliant. And I know in the Gulf of Mexico there are lots of those vessels operating which are not US flagged. For the cable laying vessel, it's a really interesting it's a really interesting case. To lay, like for the cable laying itself, it doesn't need to be Jones Act compliant. There was a ruling about that from the I don't remember, like from the custom administration that makes that clear. However, since the vessel needs to be buried in a trench, some of this trenching, depending on the kind of equipment used and the technology for trenching, sometimes that can be considered as dredging, like moving, textually, like moving part of the seabed from one place to the other. The fact of dredging a hole for the trench for the cable. So the answer is depends. Depends on the trenching technology that's used. I mean, yeah, I could, we could talk about that for hours, and I'm sure that some law
Yeah.
firm will.
One thing that is never lost on me is the amount of innovation and constant development of new technology or new techniques that are emerging in this industry
Yeah,
to continue to drive growth. So totally, totally understand when it comes to these different, whether it's a cable installation technique or diving, like, these answers, while they're there, are also often in flux as well.
yeah, yeah,
And that's what creates such an exciting and dynamic opportunity around
yeah,
this emerging industry here in the
yeah,
US. Um, there was a question that came in around average cost and time to manufacture. The question was specifically around a crew transfer vessel, but maybe you could elaborate on that and go into a WTIV or
yeah.
any of these other pieces that you might have.
So for the for a crew transfer vessel cost, I couldn't really say. Honestly, I don't really have a good examples in mind, but it's, depending on the shipyard again, it could be relatively fast, like 1 or 2 years construction. Again, that really depends on the shipyard. There are shipyards in Vietnam that are doing a lot of them that, are doing uh, maybe once every less than a year. And for, like, especially for US shipyard, that would probably be kind of a first. You should probably consider the highest side of the range. For other kind of vessel, for wind turbine installation vessel, obviously it's much longer. For instance, the one that was ordered in Texas, I think it was order was placed maybe end of 2019 or something. Uh, and the delivery is expecting end of 2023. So I think 4 years is a good assumption. And, on top of that, you need to consider, the time of negotiation and all this. So it's long. It's long, and basically, it's probably too late for the first wind farm that will be built in the US. I mean,
Yeah, all of these projects typically, we're seeing long lead times as well as long development times, even when it comes to the component manufacturing or vessel
yeah,
manufacturing.
yeah,
With CTVs, we see a number of facilities, um, vessel fabricators that are gaining these opportunities, and just on that related to cost basis, like many other fabricated components. Once an organization has done it once, they learn from that process and efficiencies can be gained. So
yeah,
it
yeah,
really provides, unique industry growth opportunity
yeah,
for us here in New York and the US.
yeah. Yeah, definitely. I mean, especially for shipbuilding, everyone is really focusing on the wind turbine installation vessel, but there are actually, like, plenty of other vessels that need to be Jones Act and need to be built here. So, even if we take this kind of, like, e- even if you take this specific vessel out of the equation, there are still a lot to be made, to be built here.
Yeah, so everyone take note of the different vessels that Noah had talked about today, and recognize the opportunities associated with them. There was a question that came in around tracking Jones Act compliant vessels that are under contract or are being fabricated. Do you know of any databases or associations or that are
Mm,
tracking tracking progress related to vessels that you could share?
Not that I know of. I mean, in a lot of company have their own, database. We do, but we don't really make it public because it's not necessarily up to date always. But I mean, typically the ship brokers would do this kind of tracking of vessel. So I mean, contacting a ship broker is probably the best thing to do. I don't want to mention any names, but the big ones, they know.
Appreciate that. I know we're coming down to the end of the hour, and so I think there's one last question that maybe we can get to around: are there existing vessels that are Jones Act compliant and serving other industries that could be utilized for offshore wind? And
Yeah,
then what's needed to make upgrades or a switch?
yeah. So typically, especially in the Gulf of Mexico, there are lots of vessels used for the oil and gas industry, for installation and operation of the oil and gas industry. So some of those vessels, like I mentioned, the anchor handling vessel, this kind of anchor handling vessel that's used already for floating oil and gas installation. So that's exactly the same kind of vessel that we need. Uh, Even for the service operation vessel, uh, it the platform supply vessel, which is like quite simple transport vessel with dynamic positioning, could be upgraded to serve as a service operation vessel. Typically, we would need to install transfer gangway, a bit more accommodation that can even be containerized accommodation. I've seen that quite a few times. So these kind of vessels are relatively easy to convert, even if it's not as good and as efficient as a you know purpose design, but it can really help to fill the gap, especially at the beginning. Um, yeah, I mean, then there are other vessels like especially all those vessels, like all the vessels for bathymetry survey, geotech survey. Those vessels are the same than the oil and gas industry. However, it's a bit more, and also for transport. However, it's more complicated when it comes to technician transport and personnel transport, like CTV, boat landing. Even if I know there are some boat landing transfer being carried out in the oil and gas industry, it's still quite different. It's not really the same technique, and usually the crew transfer vessel used in the oil and gas industry are not really used in the offshore wind industry. It's different standard, different safety standard, different shape of everything. So I don't know. At least I haven't seen
So
any used. And same for the
yeah.
wind turbine installation vessel. Even if there are some crane vessel, jackup vessel in the oil and gas industry, the height of the component that need to be installed in the offshore wind industry are really different, the height and weight. And there are no Jones Act vessels that can do that for now.
Well, no, we are right here at 1:59. We really appreciate the insight and the knowledge that you brought here for the presentation today. So I want to thank everyone else for joining us for this Learning from the Experts webinar. Just a reminder, it was recorded and presentation slides will be available at nyserda.ny.gov/ osw-webinar-series. Our next webinar will be on May 25th at 1 p.m. We'll hear from Philip Jordan with BW Research Partnership, who will be speaking on workforce development. You can register for future webinars through our events page at win.ny.gov. If you have requests for future topics or would like to hear about this series, please email us at offshorewind@nyserda.ny.gov. Thanks again for joining us, and we will see you next time. Thanks,
Thank
Noah.
you. All right.
Bye.